Hello, this is the recap for homework 2B in the text mining module of Stat 312 Data Science Applications. Before you get started on this assignment, you need to finish homework 2A, which has you install a bunch of libraries, in particular installing the tidytext and the Gutenberger library. For this particular assignment, homework 2B, you also need to install the word cloud library and the Reshape2 library. Now, Reshape2 library probably will be installed once the tidyverse is installed, so check before you try to install it. Once you've gotten those installed, then it's time to get to work. The first thing that we're going to need in this particular assignment is we're going to need a source of some text. For this particular assignment, I'm going to show you, by demonstration, Shakespeare's works as the set of texts that we're going to work from. Now, in order to do that, it's convenient to have a list of all of Shakespeare's works and the Gutenberg IDs for each of these texts. That makes it much easier to download those files. The way I've distributed this list of files for you is on Canvas as a CSV file. Here's what it looks like. It has 3 columns. One column is the Gutenberg ID, so you can see that's a 4-digit number. In this particular case, it's an integer, quantitative type. The second column is the name, which is the name of the work, so the title that Shakespeare gave it or people afterwards has given it. And then the type of work, whether it's a comedy, a tragedy, a history, or some poetry. Okay, let's get started. Fire up RStudio and get those libraries loaded. Okay, so all these libraries are up and ready. The next thing we're going to need to do is we're going to need to load in that spreadsheet I just showed you. The read CSV function will do a nice job of that. I'm going to dump it into a table I'll call Shakespeare Corpus. Okay, it's loaded it in, and you can see that it has 3 columns. The Gutenberg ID, which is numerical, the name, and the type, which are both categorical text. The other thing we're going to need is we're going to need some stop words, so let's go load those in. The tidytext module provides the standard English stop words, but since Shakespeare wrote early modern English, it's good to have those on hand too. And at least for the moment, I think it's just easier to put these guys in yourself rather than try to load them from any database. So I tend to find thee and thou and hath, thy, and a bunch of others tend to be what we need. So there's some stop words. Okay, now what we'd like to do is we'd like to bring in all of Shakespeare's works into one big, massive data frame. All right, great. This is something you can do just by simply walking through each of the elements in that Shakespeare corpus table. Let's have a look at what that Shakespeare corpus table is. So you can see the first one is 1125. That's All's Well That Ends Well. It's a comedy. And we can certainly load it in with the Gutenberg download function. We want to load, for instance, the 1125, that ID, and it's handy to pick a mirror that works, at least for me right now. This particular mirror is doing the best job. But rather than typing in 1125, we're going to want to actually use this table because as you can see, there's 38 of these guys. I don't want to have to type them in, 38 of them one after the other. That's sort of a pain. So what I'd like to do is I'd like to have the computer loop over each of these for me. R, like many other programming languages, supports loops, and so we can go ahead and use that. Now to set this up, to make sure that the loop works, I'm going to do the first one by hand. This has the benefit of creating the book data frame for me first. That way I can then proceed to have my loop add to that list. Okay, so let's do that. Well, the first work that I'd like to load is the first row of the Shakespeare corpus data. So let's use that Shakespeare corpus data. We want to grab out of that the Gutenberg ID column, and we're interested in the first entry. That would be for row 1. And our loop will just change that 1 to a 2, a 3, a 4, etc. until the end. All right, so let's go ahead and pull down that first book. Okay, there it is, brought down. Sounds good to me. So I want to repeat this process over and over and over. So the way to do this is with a for loop. And for loops in R work kind of like they do in Python, for I in some range. So what's the range? Well, the range is going to be 2 until the end. How many of these are there? Well, there's 38, so I could say 2:38. Or I could say, and this is kind of convenient to say it this way, is to say n row of the Shakespeare corpus. That way, if I decide to change my mind and load a different corpus, I can use the same code. Okay? That's the preamble to the loop. Do an open curly brackets and then type in what you want it to loop. Well, it's basically this next line here with a few changes. So let's copy that line, put it in, make a few changes. Change number 1 is that we replace the 1 with the I because that's our loop variable. The second thing is that we don't want to replace book with this. We want to add a bunch of rows. So let's add a bunch of rows. So if you use the add row command, it will add rows. All right. Looks good. Hit enter and wait. Okay, there it is. Incidentally, it took about 2 minutes. I just cut those 2 minutes out of the video. It took about 2 minutes to pull all of that down, which isn't so bad. But great. There we are. Let's proceed. Actually, it seems that those 2 minutes were wasted. I forgot add row. You have to tell it what to add rows to. Add row to the book, not just generally. Otherwise, you're going to be wasting your time. You can do it this way, or you can do it the tidyverse way with the pipe. Take your pick. But in any case, hit enter and let it crunch. Okay, there we go. This time it actually worked, and the way that you can tell is notice that we have a lot of observations of 2 variables. So if we take a look at the book, there's a lot of metadata and whatnot, but there's many, many, many different Gutenberg IDs. So different Gutenberg ID, one for each of the various ones in our corpus. And if you take a look at the last one, 1134, A Winter's Tale, 1134, A Winter's Tale. There it is. All right. Okay. Closing those guys out of the way. Let's go now start digging through this. It's really handy to clean up all of the books, which are listed by line, and tidy them up into words. Sounds like a plan. So let's save in a tidy Shakespeare. Let's save our data by piping the book through it, i.e. the book data table through it. Let's unnest tokens, and let's unnest tokens by word with text, and let's anti-join the stop words. And let's anti-join our stop words as well. Okay, let that crunch. It takes a few moments, but not too long. There we go. There's our tidy Shakespeare, 300,000 observations of 2 variables. Okay, big pile of stuff. Now, the next thing is, if you look at this, you'll notice 2 variables. The first variable is the Gutenberg ID. The second is the word. And of course, you can see there's a whole bunch of header information here. Ebook, project, Gutenberg. All of those are things that Shakespeare did not write. However, they're so infrequent that they won't make much of a big difference in the end. But what we'd like to do is we'd like to merge up the Gutenberg ID with the Gutenberg ID with the additional information, i.e. the name and the type. That way we know which word or which work and what type of work was involved for each of these words. The way to do this is with a join. So let's go ahead and do that. I'm going to modify our tidy Shakespeare, i.e. add a few columns. Let's add a few columns by way of a join. Let's join this to the Shakespeare corpus. And since Gutenberg ID is spelled a little differently in these 2 guys, we need to tell R how to match them up. So when you do an inner join, you can say inner join by, and then give it instructions for how to match them up. So the lowercase Gutenberg ID is going to match up with the Gutenberg ID. All right. Crunch, and now we can see that this first set of rows here is from A Winter's Tale. It's a comedy. And you can kind of scroll down and see all the others. There's Merchant of Venice somewhere in the middle. Okay. Sounds good to me. Now, what are the most common words in Shakespeare's work? Well, not so hard to do this. We could certainly count this guy. You could take your tidy Shakespeare and pipe that into a count. Word sort equals true to get the top words. Let that crunch a bit, and you can see that Lord and King and Sir show up rather frequently, as does enter. And you might say, wait, enter? Why is that? Oh, because that's a stage direction. That shows up kind of frequently because enter King George or something or other like that shows up rather frequently. But just as frequently, nearly so, is the word sir. I guess that's a stop word, kind of. It's a title. Fair enough. I guess Shakespeare wrote a lot about nobility. Sounds good. Well, a good way to visualize this is with word cloud. We've already got our word cloud library in hand, so we want to go ahead and make use of the word cloud library. Now, unfortunately, the word cloud library is not written for tidyverse, and so you have to wrangle data a little bit. So what we need counts of each of the words sort of separately, and then the list of words. Kind of like what we got going on right here. So let's go save that. Okay, got it loaded up. And so let's go ahead and word cloud this. This is pretty easy. You can just say word cloud. And what do we got? We've got our word counts. And the word cloud takes 2 inputs. The first is supposed to be the list of words. And the second is supposed to be word counts. It's supposed to be the numbers. So that's the ends, as you can see. And don't be a fool like me. Don't run it with default options because it'll plot every single word. And there's, well, looks like 25,000 words. That takes a while and makes a terrible looking plot. So tell it max words equals 100. That way it doesn't get too cluttered. And there you go. There are the words stacked together in a nice word cloud. The size of the word indicates its frequency. So again, King, Sir, Lord, and Enter are the top hits. And then the words are kind of spread around to make a nice picture. So that's how you get a nice word cloud. All right, now what about if you're interested in just one play? Well, that's not so hard. You just need to filter before you go ahead and do anything with it. Okay. So let's take a look at, I don't know, Much Ado About Nothing. Where's Much Ado About Nothing? Well, Much Ado About Nothing is Here it is. Here's Much Ado About Nothing. It's Gutenberg ID 1118. Now you could match on the name or you could match on the ID. It's a little easier to match on the ID, less typing, less likely to worry about issues like spaces and other sorts of things. Okay, so let's go filter for that particular Gutenberg ID out of the Tidy Shakespeare list. The Gutenberg ID column is written all in lowercase with an underscore. Fair enough. So let's look at Much Ado About Nothing. Let's take our Tidy Shakespeare. Let's filter out the Gutenberg ID. Gutenberg ID. And let's say that's equal to 1118. Sounds good. And then we're going to do our count. Actually, you don't need this sort equals true at this point. Crunch. Again, 2 columns present. So if I look at word counts much, I want to take a look at it. Yup, the N and the word columns are still there. Sounds good. So we can just word cloud this guy just as before. And you can see that, well, as you might imagine, some of the main characters show up as being important. Like Claudio is right in the middle there, and Leon, and Benedict, and Lord, and Hero, and Love, and that sort of thing. Yes, sounds about right. Sounds like Much Ado About Nothing to me. Now, let's pivot. Let's pivot to talk about sentiment analysis. Now, sentiment analysis, it can be a rather involved thing because determining whether someone is being happy or sad, maybe that's easy by telling whether they're using happy or sad words, but if they're being a little sarcastic or snarky, that can be really hard. So picking out tone from text is sentiment analysis, and that's quite difficult. We can do a much more simplistic thing here and work just simply based off of the set of words being used. Word choice being the way that we'll analyze for sentiment. Now, there's a bunch of different ways you can do this. Typically, you need a lexicon. The tidytext module has several different sentiment lexicons. One of them is the Bing lexicon. And the Bing lexicon, if we take a look at it, has got a list of words and sentiment either positive or negative. So abound gives you a positive feeling. Well, all of this wonderful things you can do with it they abound. That makes you happy. On the other hand, when R gets out of hand, you get mad and you say it's an abomination. That's clearly a negative sentiment, and so on. So someone went through the English language, probably someone by the name of Bing, if I had to guess, and labeled all of these words, labeled, in fact, a bit over 6,000 of them, as positive or negative. Sometimes it gets it wrong, or sometimes it's ambiguous, but it's not a bad start. Okay, so we've got those in hand. And if you'd like to know whether these various words in our Shakespeare are positive or negative, we just, guess what? Just join in that column of sentiments. So if we join on word rather than ID, we'll get the sentiments as a new column. Easy enough to do. Okay, so in fact, you could just say something like, oops, Tidy Shakespeare, pipe that into an inner join with the Bing sentiments. And in fact, since word is already there and word is in the Bing sentiments dataset, both of them are going to match on word by default, and that'll just go ahead and do it. And you can see improved is positive, readable, positive, proud, positive, etc. Okay, not bad. Let's just do a real quick count on this. Let's group by type. Type being the type of work, so is it a comedy or tragedy? One might imagine that if I group by type, comedies will tend to have positive sentiment, tragedies will tend to have negative. Of course, this is a vast oversimplification. But instead of counting words, let's count sentiment. And if you go ahead and do this, you'll see that, well, comedy, there are 13,000 negative words and 11,000 positive words. In histories, there's 11,800 and some odd negative words and 8,000 positive words. One thing you can see is that Shakespeare was not necessarily a purely sanguine, positive author. Even his comedies have got some sad words in them, which actually kind of is part of his appeal. Comedies are not really that much fun if everything that happens is wonderful. Comedies are more fun if they're tinged with sorrow, perhaps. Well, okay, that's a bit too far afield here. Let's let the data speak for themselves. Okay, one thing to notice from an R standpoint is this group by allows the count to pick up the right counts and give us reasonable groupings. Let's do a little bit of a plot with this. I find this is handy to plot this guy, this kind of information, with a bar plot. So let's ggplot it. We'll set as the aesthetic, the type versus n, and we'll fill with the sentiment. And let's give a bar plot. Let that crunch, and there's your bar plot. I find this default out-of-the-box bar plot's not that helpful because you really can't tell positive versus negative. They kind of look like they're the same to me, and it just simply is telling you that Shakespeare wrote a lot more comedies than he wrote histories, or at least a lot more words in his comedies. So let's change the plot a little bit. If you dodge the bars, that means bump them apart. Now you can see that generally speaking, in all of his writings, at least all the writings we're looking at here, he's got more negative words than positive across the board. But the ratio of negative to positive words is different. The ratio between negative and positive words seems to be a little closer in comedies than it is in his histories or his tragedies. Okay, this strikes me as being the situation now where, if you think about ratios and comparisons and groups and that sort of thing, really you might want to phrase this as a two-way table. Type versus positive and negative. And do a chi-squared to see whether or not this is significant. So let's make a contingency table. And that's easy enough to do by taking this whole thing we just did a moment ago. So this whole crunch right here. This bit could be turned into a contingency table by simply pivoting. And it's no longer a tidy data set when we do this because each row will not be an observation. It's a contingency table, but it's not so hard to do. The way to do this is with names from being the sentiment, and the values are from the n. In fact, actually, I don't need the C there. I can just say sent, and the values from n. And now this looks very much like a standard two-way table. Okay, well, one little wonkiness that the standard chi-squared test that's present in R wants the type column, i.e. the first column here, to be actually not indexed by numbers but indexed by names. Okay, that turns out to be a little bit irritating, but it's not so hard to do. The way to do that is to say column to row names, and then you say var equals type, equals type, and oddly enough this needs to be in regular old quotes. Now in so doing, you can see there's a slight difference. The slight difference is in the way that it rendered. This version here is a tibble, a tidyverse table. This is a standard R table. So now it's a standard R table, and it's ready to be turned into a chi-squared test. Okay, just dump that into chi-squared test. Hit enter. Crunch. Wow, very small p-value. I guess that means that the type of poetry does influence how Shakespeare chose his words. Guess that might be kind of obvious, but the data bears it out. Okay, now sentiments need not be positive or negative exactly. They can be numeric as well. So there's another sentiment lexicon available in the tidytext library that has that. So rather than being just positive or negative, here's another sentiment lexicon called AFIN. And notice far fewer words are labeled. I guess this is a little harder to label, but now you can see that they're numbers. So negative numbers, more negative numbers mean more negative sentiment. Smaller negative numbers, or negative numbers closer to 0, are more ambiguous, or more likely to be ambiguous. So alas is apparently a little less negatively sentimental than alienation. Interesting. Okay, fair enough. But amusements are definitely very positive. I guess that seems reasonable. R is a pretty good amusement, if you ask me. All right. Well, let's fold this guy in. Guess what? The word is still the word column, so we can just join this in. We'll get a new column, that being a value column. The Bing sentiments were sentiment. The affin sentiments are value. Sounds decent enough. So let's keep this around, in fact. Let's save it off. Another good old inner join. And voila. Now we have a sentimental column, a value column to tell you whether these words are positive or not, and how much they are. Okay, well, we can kind of now assess again by group, but rather than now doing positive or negative, i.e. two-way table land, now we can start to think about doing this by way of a summarization, by looking at things like means and medians. Sounds good to me. Let's do it. So pipe that in. We'll group by, type again, and now let's summarize it. Summarize, and we'll say like so. And you can see, on average, the comedies are positive, but just a little bit. So that's capturing, the mean is shifted a little bit towards the positive, I guess. Notice the two sentiment lexicons treat some of the words differently. It's far fewer in the numerical one. But, you know, I guess that's kind of still vaguely in line. And the history and the poetry are definitely negative, the tragedy as well. Oddly enough, the histories and poetry tend to use more emphatically negative words than the tragedies do. Maybe that's because the tragedies are kind of ambiguous for a long time and they sort of get worse. Whereas history, well, history's just dismal, I guess. And the poetry, you've only got a few words, so you better make it good, I guess. Just speculating. Okay, well, we can plot this, and we could plot this just like what we just did, but now we've got a distribution for each type. So the best way to get at that, I think, and maybe you'll agree, maybe you won't. I've not found a really good visualization, but ggplot will happily take this for you. And the geom count is not a bad way to go after this. So the dot's telling you more or less. So you can see that, yeah, in the comedies, Shakespeare uses about the same number of positive and negative words, so marked. Most of them are kind of not too strong. But on the comedies, he tends to kind of lean on the stronger positive words than he is on the negative ones. And on the history, things are a little more evenly balanced. Same with the tragedies and the poetry, there's just fewer of them altogether. You might like a different geom, so you might find that the violin blot is a little better. Oops, spelled it wrong. Violin, cannot spell violin. Okay, there we go. And maybe that looks better to you, maybe it doesn't. I'm not sure it's very informative. Maybe you'll want to mess around with this a bit to kind of get a better distribution. Okay. Well, finally, let's put these two ideas together, that being the word clouds and that being the the sentiment analysis, let's use the sentiment analysis to help place the words in our word cloud. So for instance, if we go back to our word cloud, some of these words here are positive, some of them are negative, like love is probably positive, and dead is probably negative, and live is probably positive, and that sort of thing. So probably, if we can get all the positive words to gravitate to one side and all the negative words to gravitate towards the other, that might be kind of handy. Okay, now to do that, what we need to do is we need to kind of reformat the data. Again, because the word cloud library is not a tidy library, you kind of got to mess around with it a bit. Okay, well, we've got our sentiment data, and one thing I failed to do in this process is fold in the Bing sentiments, the positive and negative ones, into the Shakespeare sentimental. Let's just go ahead and do that now. Okay, so now he's got a sentiment column. All right. Now, in order to do this particular analysis, what we're going to need to do is we're going to need to feed the word cloud library a table rather than a tibble, i.e. it wants a matrix that's formatted in a very particular way. So in order to do that, what we're going to need is we're going to need the tool called acast. And acast lives in the reshape2 library. I don't remember if I loaded that or not. Let's see if I did. I did. All right, so let's roll. Okay, so the data that acast needs is our sentimental data, counted based on positive or negative. And what we're going to do is we're going to feed this through this acast library, or this acast function. If you're interested exactly in what acast is good for, it's good for building contingency table-like things, but not exactly. It is a type casting library. Now, what we want to do is we want to what the type casting library. What it's doing for us is it's transforming the data very much like a contingency table, wherein we're saying one thing versus another. In particular, we're going to want to compare word versus sentiment. In R, the tilde is the versus. That's the key next to the 1. But shift the backtick, if you will. So word versus sentiment. That's what we're interested in comparing. The values for this are in N. And again, oddly enough, it needs in quotes. And anywhere it doesn't have any data, let's fill it with zeros. All right. So this acasted thing is, you can see it's not a data table. It's an array of sorts. All right. Now with that in hand, now we can take the acasted data and feed that into the word cloud. Now, it's not a word cloud exactly, it's a comparison cloud. Fine. And here we go. And you can see it's crunching along, and love is right in the middle. You've got some positive words down below, like noble in red, and heaven and fair, and some negative words like death and poor and fear. Well, that seems like that's been a pretty good adventure, exploring sentiment analysis and word clouds using all of Shakespeare. Sounds like it's a lot of work, but not so bad once you've got the power of R in your hands. Hope you enjoyed this.